Hi, my name is Linda, and I'm joined by my teammates Jenny and Steven. And today we are going to talk about the tension behavior of sustainable textiles for knit fabrics and doing a comparative analysis with traditional non-sustainable textiles. The fashion and textile industry had played a significant role in environmental degradation. Because of this, sustainable materials have emerged as promising replacements. Our goal was to assess the suitability of these sustainable alternatives for traditional textiles by comparing their mechanical properties under tensile loads. For our experiment, we focused on the fabric types, with polyester and polyester spandex as our traditional textiles, and recycled polyester, rayon, and tensile fabrics as our sustainable alternatives. For our data collection, we used the Cell Scale Biotester 5000 for biaxial loading. We prepared 3 samples for each of our 5 fabric types and conducted an equibiax, strip X, and strip Y stretch test for each sample. For fabrics that were anisotropic, we made sure to load the samples in the same mesh direction each time. A 30 millinewton preload was applied to prepare the samples, and a 30% stretch was applied for the tests.
Next, I'll talk about network architecture. We refer to Jeremy's paper here and use the code with some modification to discover models for our dataset. The left side function shows the energy function of the network, and the right figure shows the 2-fiber constitutive neural network that was used in the code. The network learns the free energy function psi as the weighted sum of the final layer, from which it derives the stress P. We also use the Atom optimizer for gradient descent and use the L0.5 regularization. This is the result for the polyester train model. And the next slide shows the result for the polyester plus spandex train model. We can see that in general, there are better results with the polyester spandex train model. In other words, the R-square was generally higher. If we apply the discovered models to the sustainable alternatives, we see that we have the best result for the tensile for both the train on polyester and train on polyester plus spandex model.
Evaluating our discovered models against rayon and recycled polyester test data reveals poor predictive performance with very low goodness of fit across the board. This poor performance is likely due to plastic deformation during loading of the material samples. Although the samples were preconditioned with a 30% stretch, artifacts characteristic of plastic deformation appeared during data collection. These artifacts are highlighted in the bottom plots. The high R-squared between the discovered models and tensile suggests that tensile presents a mechanically similar substitute material. The poor correlation of rayon and recycled polyester indicates both materials have dramatically different properties and may not be suitable substitutes. With more resources and time, we think it would be beneficial to include regularization to reduce the number of terms in our models. Additionally, we would expand the scope of our testing methods and materials. Ideally, we would evaluate more anisotropic sample orientations and investigate other traditional textiles with potential substitutions.